the way I had been taught to think about computers was just wrong. And it was deeply ingrained in the way the tools, languages, I was limited in that era by latency and bandwidth to process data.
So you're the Chief Scientist Officer.
Yes.
What does that mean?
Jump is very liberal with titles, I think.
So you picked it?
No, I didn't pick it. It was one day they showed up and said, "You're Chief Scientist." And so I said, "Oh, that's cool. Should I do anything different?" They're like, "No." So what does that mean? I've been there a long time. I've worked on all aspects of their technology stack. So I'm very familiar with how the parts are put together. Parts of it, at least, have been very successful for the firm. So they've, given me nice titles and things like that. But in terms of my daily responsibilities, I mostly play with computers, try to find cool things to do with the technology. There's a lot of people that are working on my team. They're very similar backgrounds, similar kind of mindsets, and just, trying to figure out how to, make it better.
Make it better.
Yeah.
I don't think I've met many Chief Scientist Officer. I think it's very interesting. You studied electrical engineering?
Correct.
And computer science?
Yeah. When I'm around engineers, they think I'm a physicist, and when I'm around physicists, they think I'm an engineer.
I think it's a big flex.
So
not many people can say that.
No, but I mean, from my perspective, engineers think I'm too theoretical, and physicists think I'm too applied.
So if that's interesting to me, because if we talk about theoretical physics, which we're not, but one of your, I think, very famous statement is the speed of light is too slow.
Yeah, it is. It's quite problematic, actually. Most of my job is dealing with the fact the speed of light is not as fast as what people want it to be for their ambitions.
Can you talk to me about that? What do you mean by that? And how you also mentioned that in an essay on jump trading.
Yeah.
What do you mean by that? What are the issues that you've seen?
So I think in a lot of areas, and this is pervasive. There are so many areas you can get into. The way people think about computers, the way they've been taught, the way languages work, the way the tooling works. People focus on what it takes to do compute. Compute is cheap. Compute has been cheap forever. And if you just think about how semiconductors have progressed and transistor size have gotten smaller, every time I shrink a transistor by a factor of 2, I get 4 times the amount of compute that I can fit on the same area of a die. Compute keeps growing, but the amount of data I can bring into that compute doesn't grow as fast. And, the boxes are still about the same size, a rack's still about the same size. Getting data from far away, Chicago and New York haven't gotten any closer. And so moving those things around, you find over time you become more and more limited by latency and bandwidth of these systems. Now, in my case, I recognized that when I was a grad student, not because I was looking for it, just because I wanted to get my thesis done faster. And I was writing simulations, and I noticed they were not at all as fast as they should be, or at least as fast as I thought they should. And I was doing all of the right things the way people have been taught to think about computers. And so I started, poking around because, I was pretty motivated. It was the first .com boom. I'm like, I could be, here slaving away, writing a lot of LaTeX, or I could be like, going out there and working. And also had a baby kid, and so I was like really
a lot
motivated.
of things happened.
And really wanted to get my thesis done, and I just discovered the way I had been taught to think about computers was just wrong. And it was deeply ingrained in the way the tools, languages, I was limited in that era already by latency and bandwidth to process data. And so I re-architected everything. My codes got done faster, my thesis got done faster. And a lot of things I've done since then have just been that same experience. Like, it has been the case, computing has been limited by moving data around for a long time, but everything has been geared to this model of like, no, just worry about the compute, don't worry about where things are placed. What was the other part of your question? I guess it was the speed of light is too slow. So if you want to put numbers around that, one thing people who have the misfortune of encountering me at Jump will just usually hear me mumble at them, the speed of light's about 1 foot per nanosecond. But you look at how fast processors are. You have like a 3 gigahertz processor. It's doing one cycle, that's 4 inches light can travel. It can't go very far. And so when people are thinking about stuff and they want to get stuff done fast, they're talking about building these big global geographically distributed systems, like you need to be first and foremost thinking about how you're going to move that data around. But virtually no one thinks it's an afterthought. And then like when it shows up, they're like, wait, you mean there's a problem with the speed of light? Like, yes, there's a very real problem with the speed of light.
So you speaking, and I'm not going to quote you for the entire time, don't worry about it.
No, that's fine.
But actually this is leading me to something else that you said.
Saves me the effort of talking.
Well, I want to acknowledge the things that you've said, which is going to build up into what we're talking about.
Okay.
So you talked about data, and you said bottleneck is often data motion rather than arithmetic.
Like the first and foremost consideration on designing any system, and you can't ignore performance to the end. You can't just say, okay, I'm going to kind of get it working, and then I think after I get it working, I'll go back and I'll do a little tuning pass. It's like, no, if you didn't think about getting the data to flow through the system in the right way, getting things right local next to each other, so the next part of the calculation has the data already in its hand as it gets produced, you're never going to see high performance. And those are decisions that are architectural decisions. They're the very first decisions you make in a project. And so people have been taught, like one of the things is like, oh, premature optimization, root of all evil. Don't even think about it. It's like, don't you know Moore's law? Eventually, your computer will be infinitely fast. Where it's like, no, you might get an infinitely fast processor, but you're not going to get an infinitely fast speed of light. You're not going to be able to feed these things. And so you really have to be completely focused on data motion, and it has to be the first thing you think about. You can't do performance at the end. So.
Is the data motion something that you've been trying to solve for?
The entire time.
How close are you to solving it?
Well, I mean,
are you satisfied with?
Well, I mean, to solve it, and maybe the sense you're referring to, I have to change the speed of light. So no, I'm not satisfied at all. That's not happening. I think the biggest difficulty here, like from my standpoint, I know individually if I am asked to do a project like Fire Dancer, or the codes I was doing for Los Alamos, or the simulations I was doing at Shaw, or for that matter, working on projects like Shelby, I know what needs to be done. Like I'm going to go into it. I'm going to know. I know if you want this thing to have legs, we need to approach it with the right mindset. We need to approach it with thinking about how information is going to flow through the system, and what we need to do to architect around that, and where the physical constraints are, and then build from that. And to be honest, it's not all that hard to do. The thing here is that mental model that people have is they have been trained to do the wrong thing from the get-go. So they get to the end and they have this really suboptimal result. And then they're like, can I fix it? It's like, well, no, you have to kind of redo it because it's totally backwards. Yeah. And so that's like, for example, when doing the Project Fire Dancer, coming in, like saying, hey, what was our approach to it? It was to run along the data flow for how a transaction gets processed and just incrementally replace everything with high performance versions. And we knew that, you do the front end stage, you're not going to see a big impact until you get to the end. Get the second, you're still not going to see it. You have to do it all because you have not, started from a platform which was designed with the high performance and data flow in mind. And we also knew with that, and this will also then tie into projects like 00 and projects like Shelby. Okay, you get a local node working correctly, great. But if you're running it on a dial-up modem from the 90s, you're going to be very limited to what you can do. You're going to need to put real networks in there. And that's certainly something that is not appreciated, that if you're looking at the competitors in Web 2, the things that big tech, traditional finance, they run all of their critical infrastructure on really high performance private networks they built to their spec. So it's like saying, hey, you see all these things like, hey, we're going to go compete, we're going to go disrupt these areas. I'm like, cool, that's nice. You're going to have a lot of trouble doing that if you're on that, dial-up modem kind of line. And it's like, I appreciate the sentiment of like, we want to make sure everyone can have access, low barriers. We're really supportive of that from many, many levels. At the same time, you want to handle millions of transactions per second. You want to go toe-to-toe with these big established things. You need to bring the tools and the infrastructure necessary to even have a chance. You see this now like taken to the extreme with a lot of the stuff going on in AI. Where just ridiculous amounts of computer being thrown at it, but it's like did you think about doing it out? You see like all the excitement around, say, a DeepSeek, and from my perspective, it's like, well, they took some effort to optimize the code. I'm like, and yeah, they got a big result because things are running so inefficient, but this should not be a surprise. So am I satisfied? It's a mixed bag.
It's mixed feelings.
Yes.
So why do you think there isn't more people who are thinking about that first and foremost?
So something, with exposure to crypto and also finance, but crypto makes it even more evident, is the incentives need to be there. And the incentives don't really exist there. Like, I think one of the things that goes on, this is highly relevant to a project like Shelby, everything that I'm describing, there is no reason a cloud provider couldn't offer a service that has high performance and low cost and all those other things. But their incentives aren't aligned with their users' incentives. And so if you're sitting around saying, hey, I want to store my data here, but I want the flexibility to move it over there, they're like, because maybe that's where the cheaper compute is, or they want to try this thing. Like, they have no motivation to do this. Like, no, it's like we want you to keep your data here, and we want your data to be sticky. We want to be, so we're going to charge really high costs and all of this. Okay, why are they doing that? Well, it benefits them. They've been very successful with that business model, but does it benefit the users? Not as much. So the incentives aren't there. I look at the overall thing. There is, if I like, what has been the secret sauce for a company like Jump in traditional finance or companies in big tech? It's usually they built the networks that were sufficient to handle the kind of scale they're operating at. They built the storage systems that were sufficient to handle the scale, and none of that was stuff that could get off the shelf. If you look at the stuff that they open source to get goodwill and help with recruiting, it's never that stuff. It's like, no. Like we're going to show you some neat stuff we've done over here with machine learning, and it is neat stuff. But I'm saying hey, can we use your network? Can we like use your thing? And like, no. Like we're not going to show you that. So look at the incentives. Their incentives aren't really aligned. So people are looking at it and they're saying, well, everything you're saying is fine, but I really, the metrics that I'm given, the way I've been taught to think about the problem, the funding that I have for my startup, I just need to do it this traditional way. So all of that inertia has been all kind of fighting it.
So it's a mindset. It's the way people are being taught and trained, as you mentioned.
Yeah.
That's probably the biggest blocker.
Yeah.
In the advancement.
Yeah.
You talked about Shelby. I guess my first question, before we go a little bit deeper into what Shelby is doing, your involvement, and why you see it as something being important, what was your first taste of blockchain technologies? When was it, and what was it through?
I mean, it'd probably be the original Bitcoin white paper, but that was as a spectator. So, no, it's if I go back like very early on, like given the nature of the roles, and just I'm generally a geeky guy who likes to keep up with all things tech. When the first cryptocurrencies were being talked about, or like you even go back further, like almost everyone liked to get Bruce Schneier's Applied Cryptography book and at least pretend they knew something about it. When those papers came out, I was kind of aware of them. Did not have the foresight to be like, and I should just go mine a bunch and like make sure to keep it all on a hard drive I don't put into a landfill. I didn't have any of that. I just kind of looked at it. I said, that looks really kind of cool. But what's it for? And so it wasn't obvious to me what the use case. I mean, at the time, there's a lot of talk like, hey, this can be good for like transferring money overseas and other things like that. And so I'm like, okay, well, I'm based in the U.S. I don't really have that problem. So I'm like, maybe that's a good use case for it. Maybe it's not. But like it's cool looking, but I'm not really sure what it's for. And so I'd kind of keep an eye on it, but I wasn't, really involved in it. I certainly had a lot on my plate with the traditional side of Jump and all those things. Fast forward a little bit. One of the struggles, and this is related to what I mentioned before about, firms like Google, they'll give away a lot of cool tech, but if you actually pay attention, it's not necessarily the tech that you would need to make something that's really competitive with a big tech kind of company. Kind of with that, those companies have built a lot of mind share. So like you're trying to recruit people and you're showing up at, a big name university du jour and you're like, hey, we do a lot of cool technology. You get a lot of feedback from the market almost immediately. You don't have to spend 2 years and fighting all these things to get things deployed. We do stuff with, ASICs and fiber optics, like everything you go. And they don't know anything about you. They've never heard of you. They've been essentially trained in this case that there is no technology outside of Silicon Valley. And so they're like, wait, you're in Chicago? Like, there's no technology in Chicago. Like it doesn't exist. And like never heard, but they've heard of all these big tech companies, and you have a problem with mindshare. And so one of the things that we established was a office near University of Illinois or Urbana-Champaign, and a lot of that was like saying we need to engage with these communities so they know we exist, but we also needed technical projects for them to do. And in looking for technical projects, it had to be something that was like they could do that was relevant to traditional finance. And the thing that ended up fitting the bill was crypto. And so it's like, okay, well, hey, we can give them essentially, here's this new kind of thing, that's something they might be interested in.
What year was that?
Mid 2010s. Very, 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 very early. And so they were kind of playing around with it, but for the most part, I was aware that was going on. Occasionally, I might be asked to go down and, talk to some of the interns or like say, hey, like, maybe, don't go out to the West Coast, come up and just throw out the road. You can do more of this. But at the time, it was, like you said, very early. And there's still a lot of questions like, what's it for? And there's like a lot of ambitions within the area, but it was also just really, really early, really, really immature on almost every single level. So I was kind of aware of the stuff going down there, but not really involved. It was still very, very, very spectator. Where things really started picking up would be in the early 2020s for me. And that would have been, around the time when, crypto in general was starting to get a lot more attention and becoming something that was like this is actually a substantial part of our business and we need to make it enterprise grade. And so I was like saying, Kevin, why don't your team start taking a look around and seeing what can be done here. And there were a lot of different things floating around as potential projects. There were areas where we were kicking the tires of various stuff. And out of that is where doing Fire Dancer came. And a lot of the discussion was looking at it saying, hey, given what their ambitions, a lot of this is they're trying to make a decentralized version, a permissionless version of a lot of the infrastructure that we already know in traditional finance very well. And, for the good or bad in all their ways. And so like we have a lot of technology that's relevant to that. We have to be comfortable open sourcing a lot of that technology. And that was certainly something I, give a lot of credit to Jump being willing to do that. I think a lot of our competitors would be like, no way you're going to do that. But a lot of it was like,
I think it's very important in the space to be open source.
Yeah, no, I think it's really important too. I also, I have a personal interest in that because I've done a lot of cool stuff and I would like to show it to people.
See, that's why I want you to talk about it to people.
Yes. And so I mentioned being in the wilderness, like when people want to talk to me, like that's unusual. Like, people don't even know I exist.
They do.
So, was happy to open source it. I was very worried when we started open sourcing it, is that like one of the big things we noticed in crypto was they had a very skewed perception from the media as to what goes on in finance. Their kind of thing is watching a movie like Wall Street or watching a Wolf of Wall Street or other things like that. And so they're kind of thinking like that doesn't look like technology. And I'm like looking around, like most of us have PhDs and are from STEM and we're more likely to quote Monty Python than anything like that.
So Frankendancer came first, then Fire Dance.
Yes.
00.
Yes.
Shelby.
Yes.
We're getting into Shelby now.
Yeah.
How would you describe the Shelby product from your perspective, Jump's perspective?
Decentralized high performance storage, a hot store. I give the kind of short marketing terms, but it's really storage that is meant to be cost and performance competitive with existing cloud products in Web 2.
AWS, Google Cloud.
But, still remaining decentralized, having aligned incentives between the users so that people have that flexibility to move data around.
Why does it need to be decentralized?
I think a lot of that is to create that aligned incentive structure.
So ownership.
Yeah. Like the thing here, when you we looked at the cloud, the performance is pretty good. They've done a decent job there, but the economic models don't work for us. So like from our development, we were going down this path of doing all this machine learning, and we had really, really fast strategies, but they needed to get smarter. We're putting more and more machine learning. We have to essentially take data from the finance data centers where it goes, and you don't control those. Like you show up and an exchange says, hey, if you want to trade here, we'll tell you what your rack is going to be like. We're going to tell you your power budget. We're going to tell you your cooling and all that. You don't have control. It's like, okay, cool. I've set up my strategies. I've integrated into their environment. You're doing your trading. Okay, cool. You want to train your strategies. You want to improve them. Well, I'm going to take the information. I'm going to take the things that I've learned, the packet captures I've made. Well, I'm not going to train there. Those things aren't optimal. They're not big clusters of GPUs that are all set up. So the power's not right. The cooling's not. Nothing's right about that for training. So I need to take those and I need to move them to data centers where you've set up all that power and cooling and all the things for that. Now, we were doing that before cloud was a mature technology. And we were hyper-focused on trading. And this was like one thing that, from my point of view, I don't have a background in trading. I didn't come from there. I look at this, I'm like, this is an interesting commercializable technology. And so you kind of like float the trial balloon. And at the time, the reaction was like, that has nothing to do with making our trading more competitive. So I'm like, okay, cool, that's fine. But you go forward a little bit and then you say, hey, all this cloud stuff is around and you are hiring people and they're like, hey, well, at the last place I worked, we were all doing stuff in the cloud. Why aren't you doing stuff in the cloud? And so you're like, well, maybe we should take a look at it. You take a look and like, okay, they got some good technology here. But you kind of price out the cost models and it's like, this is too expensive. Like we've already built all this stuff. It's really good for at least our needs. Moving into cloud would be a big step backwards so it's like, it's going to cost us more. We're going to lose a lot of the, tuning, the way the networks, the way the storage works for the way we're training stuff. And so we never really did that migration, but then we do projects like a Fire Dancer and we see that there's a lot of reception. We see there's a lot of demand and there's a lot of people who are interested in exploring these decentralized systems. It's like, okay. And instead the mindset is kind of changing saying, gee, we, open sourced a little bit of our technology stack and it got a really big reception. What else do we got? And so I'm like, well, it was pretty obvious and something I was saying from day one in a project like Fire Dancer, like we can make you a fast validator, but that won't do anything unless you put it on a fast network. And everyone's like, don't you know the internet is like a solved problem? And I'm like, oh wait, you think the internet is fast? So I'm like, oh, you think the internet's decentralized? I'm like, well, it's like
it's a matter of perspective.
Yeah. So it's like actually no. Now, like, how do you build a thing like a decentralized network? Well, that's not really our thing. That's why we brought in people like 00. Now you look at Shelby, it's essentially the same story again, saying, okay, we like 00, it's launched. There's the mainnet beta out. It's already got like 30% of stake of Solana running on it. Saying like, okay, hey, what else do we got? And I'm like, well, we got distributed storage technology. But like in the past, we're always worried, like, would that be a problem to open source? Would be, and the realization here is like, no, there's a lot of opportunity out here, especially beyond trading for this kind of technology. At the same time, like, what do we know about that? Like that's where we essentially are partnering with Aptos to say, hey, they're bringing in a lot of expertise from people outside trading to connect with those communities and build up that infrastructure.
So what made you and Jump look at Aptos and think this is the right infrastructure, this is the right layer one to build a product like Shelby?
So a lot of it was like, well, first we needed a chain that had, really focused on performance from the get-go. And a really important part of that was consensus. Solana also had that, but at the time they weren't considering things like an Alpenglow and still haven't deployed that. Like things like Aptos had that sub-second finality that we would need for the responsiveness in this. So that was at least one. Now, I think the other aspects here are you also need the low cost and the kind of scalability, but that was like I don't want to de-emphasize that because they're really important things. At the same time, like from my perspective, when I first started this and I was saying the performance here is nowhere where it needs to be competitive with big tech and traditional finance, everyone's just like, what are you talking about? And I'm like, oh, you don't know what the competitiveness is. One of the big shocks to me is like now things like Aptos do exist, and there's a lot of other things that people are like now believe performance is possible in a blockchain. They've designed that, and so certainly we needed a fast chain, and a really critical feature was we needed a chain that had really, really fast finality to be able to run the economic logic of the Shelby smart contract. So that was one aspect, but the bigger aspect, I think, was the cultural kind of compatibility. There were shared values here. Like they came to crypto, kind of like they were like, Meta, big tech, the national, they came into crypto, but they have a lot of that DNA of like knowing what big systems look like in a traditional area, what it would need to be to compete with those systems. And so they were early into crypto, early to take it seriously. They had the kind of enterprise, global scale, distributed system experience. They also had a lot of similar background in like shared values. And so you asked about being at Los Alamos National Labs supercomputing. I look at Avery like, well, you can say that about an Avery. A lot of people we're working with have like done academic research in these STEM areas. They have those things. And so it's like we're looking at them and like, okay, it's kind of a big tech version of us. Yes, yeah. And so those shared culture and values, I think, have made the project work much better. And it wasn't a thing where I was having to go in and be like, latency is a thing and you have to care about it. It's like
convincing them that.
That wasn't necessary. Like they had already built systems. They already knew what those problems were. And so that, short-circuited a lot. We could get to work on what it actually takes to do it in a decentralized, permissionless context.
Is there we talked about FireDancer a little bit. Is there, if so, which are the lessons from FireDancer's development that directly impacted the way you looked and are currently developing Shelby?
I expected from my past experience that there would need to be an educational component. I was already aware, getting people to recognize that you're not actually compute limited, you're actually data motion limited, and you need to think about designing systems like that. I thought that would need to happen, but it's one thing to kind of understand it than to actually do it and actually feel that. And that's been difficult. It's also been made difficult because being, a big company and, have a lot of restrictions on public speaking and so forth, like our ability to engage the public also is like difficult if you want to engage with these things like, hey, I want to do a big exercise and like show you like why you need to care about this and why the important metrics is maybe not, the flop count or the operation, but the important metrics are more things about like bandwidth and latency and jitter and things like that. Like we're actually designing these systems. It's like fine, but it's also very difficult if being out there on social media is very difficult for me. So that part of the engagement,
and it's a big part of crypto.
Yeah, and it's a big part of crypto. Yeah. So that's been difficult. And that also goes to with a lot of these things, partnering with an Aptos or partnering with a 00. It's a lot easier for them to engage just institutionally than it is for us. So those are, I think, some of the important lessons. I think another one, and we anticipated it, but again, doing it is different from just kind of saying like, hey, this, was that you take for granted how easy it is to do certain classes of things in a permissioned environment. And so if I'm saying that, like we connect with an exchange, you're going to sign a contract with the exchange that, summarizing in uber simplified terms, is basically don't be a jerk. So you're trading on the exchange, but if you start doing things to the exchange that are like, they're going to cut you off and and say goodbye. Like it's a permission network. So their solution to problems of like, how do you deal with a denial of service attack is like, we unplug the person who is attacking us. You're in a permissionless environment. It is very easy in a permissionless environment to solve those problems in a way that kills the benefit of decentralization or kills your ability to do performance and scale. It doesn't make it impossible, but it's really subtle and you have to think about it. And a big part of thinking about it, and I alluded to this earlier with the incentives, is having this new knob of essentially setting up the economic incentives that bad behavior is economically disincentivized, as opposed to just saying like, well, that person's behaving badly, unplug their wire. So that's been an area where like thinking, how do you solve problems in that? It feels a lot like an economic version of designing lock-free algorithms in computer science, where it's like, okay, I'm trying to do a big thing in parallel. What I would love to do is just put, anytime there could be a conflict, put just a big lock on something. But then you're really not running in parallel. Everything just kind of serializing there, everything runs slow. You've created kind of a central thing that is just stopping you getting any of the benefit from having all the things running asynchronously and concurrently. But when you actually want things truly to run asynchronous and concurrently, you're having to deal with all these really subtle problems of like, how do I make sure that this person doesn't accidentally see this in this order, and like, all these little things like that. And the same problems occur when we're like looking at fire ants and saying, okay, we no longer have the tool of just saying, that's a bad actor, unplug them. Like, okay, there's going to be bad actors. How do you design a system that
doesn't benefit them? Yeah.
Doesn't benefit them, maintains the benefits of decentralization, maintains permissionless behaviors, and doesn't kill your performance. And those we want to learn a lot of lessons, but they're also really hard problems.
It's problems about all of them can be solved individually, but combining them together is the hard part.
Oh yeah. Well, and this is something where I'm definitely outside the area where especially I'm going to be like, I'm really grateful for the Aptos team. A lot of the economic expertise they brought in this area, and you can see some of this in the white paper, of coming up with the models to create the incentive structures, all of that. Like that is not my natural background. I'm totally comfortable talking with you about like how you can structure your code for lock-free algorithms and all that stuff, and I can kind of see there's an analogy, but I haven't actually done it. I think bringing in the Aptos folk and a lot of the expertise they brought there, and I'm like reading that part, like this part's really clever. I'm like really impressed with the work.
Collaboration.
So, yes, I think it's been great. This will sound like a glib answer, but it's not really a glib answer, but I would hope everybody. At the end of the day, almost everybody is using cloud storage in some form. They're not using it directly. They're using it through applications. But if you're like taking a picture on your cell phone and it's being synced to the cloud, you're using cloud storage. Now, there are many layers between you. Are you directly interacting with the APIs and stuff? No, you're not. But like just the kind of inconvenience people have saying, I bought this cell phone and I'm going to a different carrier, or I'm switching ecosystems or whatever. Can I move? Like all the inconvenience, like those are the kinds of things where like those are side effects of the cost models, the walled gardens, all those things. But if I'm like looking, what are the use cases though? Are the use cases to say like, hey, why don't we have people sync their image? Like that's not really the target use case. I mean, that could be an app built on top of it, but then who are you actually the direct user? Direct user would be like application developers writing those large scale services. So what are really the kinds of services that we've thought about in designing? Well, there's already been a lot of storage protocols out there for Web3, and we've looked at all of them, and they are really targeting the cold storage use case, which is kind of like, capacity is fairly cheap. You can put your stuff in there, and if it's archival, you're just putting it in there just in case. Like, maybe someday it might be interesting to pull it up, but you're just having it around there for that. You're not trying to read it very aggressively. But a lot of these applications that would have really broad impact, the ones that go for everyone, are things like streaming services where you got a lot of people, they're trying to pull data at really kind of high K4 rates. You have things like machine learning where people have these massive data sets. They're running all sorts of models on top of them or various parameter fits, and they're reading data a lot and they're pulling huge volumes of data. Those are applications that traditional Web3 things can't. And if you look at the users of those applications, they feel a lot of pain because they're like, okay, well, I have all of my data here in this cloud, but the cheap computing is over there, but there are these artificial barriers to moving stuff around. And so like I just want to move my data where it's cheap and I want to be able to process it. It's like, okay, well, to be able to do that, you need to have a service that can handle those kinds of loads, but also has an incentive structure where it wants you to do that, where it's supportive of you doing that, not one which is fighting you saying, no, don't you even think about moving your data outside our ecosystem. Keep your data over here and like in my little walled garden. It's like, okay, so who do you think can benefit? Well, I think a lot of people are being impacted by that either directly in the cases of like, developers writing a streaming or machine learning, or indirectly the users of said services who may not realize they're using cloud storage, but they are still dealing with the fact like, why can't I move my photos?
Yeah. So technically, everyone, directly or indirectly, the first one though being applications that will highly benefit from creating a better user experience.
Yes, and those that are really read intensive, like if you want to store some data and never look at it, I mean, fine. I mean, you could actually just delete it and keep your fingers crossed. But yeah, that's really where our head is at, and we don't think that there's anyone who even attempted to do anything like this. And I think one of the reasons here is products like 00 weren't available to build it on. Like building this on top of a public internet, when you look at the existing cloud providers, they're not trying to do that. And so it's like saying, hey, we now have the underlying physical infrastructure to do something like this. We aren't trying to lock you into an ecosystem, but we as users of that are really allergic to trying to be locked into those ecosystems. And so it's like we think that a lot of people could benefit from this, and that's really where our head's at.
And now there's products you mentioned like 00 who have been built which allow to build a product like Shelby that's actually going to be performant in a way.
Yes. Yeah.
Clean. Well, thank you so much.
Thank you.
Kevin, I really appreciate it. Is there anything else that you want to mention?
I've said many words. So
thank you so much. I really appreciate your time.
Appreciate it. Thank you for having me again.
I'm excited to see Shelby go live.
Excellent. Well, so are we.
Thank you.
Okay.
Thank you so much.